Hi, my name is Glenn Weinreb, and today we're going to look at how we could potentially reduce the cost of green electricity with a new technique for building solar farms. But first, let's review how much material is used by the different methods of making electricity. This graph shows the weight of material per electricity generated for each method of producing electrical power. As one can see, solar farms use about as much material as hydroelectric dams. This is because solar farms are spread out over a very large surface area. In theory, we should be able to build these with less material to reduce cost and reduce emissions associated with making material. The traditional solar farm uses silicon solar cells to convert light to electricity. These are delicate and are therefore protected by a sheet of glass. The glass is heavy and therefore requires a metal structure to hold it in place. And the structure must be strong to handle high winds during a storm. Unfortunately, this consumes a lot of material. Alternatively, flexible thin film solar material could be unrolled directly onto soil in a manner similar to unrolling a carpet onto a surface. For example, 4 rows of flexible solar could be set up with each row measuring 2 meters wide by 100 meters long. Prior to unrolling, the land could be shaped with earth-moving equipment under computer control. Thin film solar mounted on 2 millimeter thick plastic is rollable, resistant to hailstones, and does not need glass protection. Also, it has lower conversion efficiency and degrades faster over time. However, what really matters is the cost per unit electricity generated and not electricity generated per square meter of land. To hold the flexible solar in place, an installation machine would install a lower anchoring layer, perhaps 20 inches below the surface. This underground layer might be a metal mesh that is held down with soil and connected to the top layer with metal links. Ultimately, the weight of the soil would hold it together during a storm. The installation machine would need to unroll both layers, place soil in between, and connect the layers with metal links. This so-called solar tractor might be similar to what we see on today's farm. We asked Grok to generate some images, and this is what it came up with. We also queried ChatGPT, and it produced a different concept. Okay, not bad for a computer. The solar material would need to be fabricated in a factory with a low-cost roll-to-roll process. Low cost is important since we need solar plus batteries to cost less than fossil fuel. Fortunately, roll-to-roll manufacturing with plastic is easier than working with delicate silicon solar cells. As you might recall, erosion is a process by which particles of soil are moved by flowing water. To prevent this from happening under the flexible solar, a drainage system would be needed that controls rainwater. For example, water might flow in troughs into a drainage pipe and then to a collection area. Accumulated water could potentially help clean the flexible solar. For example, it could be sprayed under pressure by a custom machine that looks similar to farm irrigation equipment. Okay, so how might this get started? Investors would consider this too complex and too risky. Therefore, initial support would be needed from climate money. This does not seek a return on investment and instead aims to save the planet from climate change. Sources include high net worth individuals, foundations, and governments. For details, see video number 3. Okay, so what might climate money do? Well, experimental beds of flexible solar would be built by hand and monitored over time, and custom machines would be designed, prototyped, and debugged. This includes machines that fabricate rolls of flexible solar in a factory, install beds in the field, and keep the material clean. Eventually, risks to investors would become tolerable, and they could then build on initial efforts made by climate money. For details, click on the link in the description below, and for more Climate Lab videos, visit www.aplantosavetheplanet.org. Okay, that's it for me, and I'll talk to y'all real soon.